Hello, welcome everyone. Welcome to the presentation of the video streaming assignment that is based on the two protocols RTSP and RTP. So let's look at RTSP first. Real-time streaming protocol is an application level network communication system that transfers real-time data from multimedia to an endpoint device by communicating directly with the server streaming the data. This protocol establishes and controls the media stream between client devices and servers by serving as a network remote control for time synchronized streams of continuous media such as audio and video. When a user or application attempts to stream video from a remote source, the client device sends an RTSP request to the server to determine the available options such as pause, play, and record. The server then returns a list of the types of requests it can accept through RTSP. Now let's see about RTP. Real-time Transport Protocol is designed to handle real-time traffic like video and audio. RTP developed on the user datagram protocol which helps transport audio, video and media traffic in real time while minimizing jitter and packet loss. Audio or video data blocks from the transmission side of a multimedia application are wrapped in RTP packets, and each RTP packet is wrapped in a UDP segment. This means that RTP is a protocol that works on top of UDP. After discussing in brief the concepts of RTP and RTSP, let us now move over the code of client launcher model. Here the server address is taken from the first argument of the command line. Similarly, the server port, RTP port, and the file name are taken from the second, third, and the fourth arguments respectively. A new client is launched using all these arguments. Okay, next is the client model. The state is initialized using the init. The RTSP version and the transport protocol are set accordingly. In this function, those arguments that were provided in the client launcher model are now assigned to the respective variables. The RTSP sequence number and session ID are both initialized with 0. The create widgets function is used to develop a GUI, that is graphical user interface. This has 4 buttons: setup, play, pause and tear down. The setup movie function is used to handle the setup button, in which if the client state is in initial state, then a request for setup is sent to the server. The exit client function is used to handle the tear down button. This is to destroy the connection between client and server. The pause movie function handles the pause button and play movie function handles the play button. The connect to server function creates a new socket and tries to connect with the server using the server address and the server port. The portion which was given for completion has been completed using the following snippet of the code. Under the send RTSP request function, if the client is in its initial state and it receives a setup request, we will first increase the sequence number by 1. Next, write a request for the connection setup. This request consists of the file name, RTSP version, sequence number, transport protocol that is being used and the client port number. Else if the request received is that of play and that the client is in the ready state, then we increase the sequence number by 1 and write a play request accordingly. Else if request received is for pause and if the current state is that of the playing, then we increase the sequence number by 1 and write the pause request. Similar is the case for tear down request. To keep a track of what request was sent, each time we set the request sent variable to that particular type of the request sent. Now we define the function to receive the RTSP reply from the server. First we decode the reply. Next we check if the request sent is tear down. Then we shall close the socket. Defining the function parse RTSP reply. If the setup request is sent, then change the state to ready and open an RTP port using the open RTP function, which I will explain soon. Next, if the request sent is play, then change the state to play and so on and so forth. The open RTP function where we open the RTP socket using the socket system call. Here we set the timeout to 0.5 second. Next, we bind the socket to the address using the RTP port given by the client user. Let us have a look at the RTP packet module. Here we have added the header information in the payload. Two bits are used for indicating the 2 bits are used for indicating the version field. 1 bit each for padding, extension, and marker. 7 bits for the payload type PT. The sequence number takes two sets of 8 bits, each totaling to 16 bits. Timestamp as well as SSRC are divided into 4 sets of 8 bits each. These functions are used to extract the different fields like RTP version, sequence number, timestamp, etc. The get payload function is used to get the original payload excluding the header. The get packet function is used to return the packet with the header and payload. Now we look at the implementation of the code from the server side. The first command line argument is used as the server port. Next, we create an RTSP socket using the socket system call and try to bind it with the server port. We go into an infinite loop until the client sends the connection request. Now, once the connection request is received, we call the server worker module. In the server worker, after initializing the variables, in the receive request function, the data is decoded. Then in the process RTSP request function, we extract information such as the request type, file name, and the RTSP sequence number. If the request type is set up and the state is init, then we begin the streaming of the video and thus change the state to ready and send a 200 OK status code. If the request type is play, we update the state to playing and create a new socket for RTP, followed by a 200 OK status code. Such a methodology is followed for pause and teardown request. The send RTP function is used to send the RTP packets over the UDP. Make RTP for breaking up the data in the video into several packets and add the RTP header using the encode function. The last function, reply RTSP, is used to send RTSP reply to client and will generate error messages if in case the requested file is not found or there is some connection error. Now let's look at the implementation of code. So here the left PowerShell is indicating the client side and the right PowerShell is indicating the server side. Here we have launched the server side using this command where the number indicating the server port. And the left side we launched the client side using this command where the numbers are indicating the server port and RTP port respectively. Now as we can see, there are 4 buttons: setup, play, pause and tear down. So now let's set up a connection between client and server. So as we can see, the client requested for the setup and the server received the setup request and the connection established. Now let's play the video. So as we can see, the video has been played and the sequence number is increasing. Now let's pause the video. So as we can see, the client requested for pause and the server received the pause request. Now let's play the video again. So the sequence number is increasing again from where it stopped. Now let's break the connection between client and server by clicking on the tear down button. So client requested to break the connection and server received the request and the connection is broken. So this is all from our side and here are my team members. Thank you.